Okay, it's Wayne Patterson from Grain Air Australia. Now, as you guys know, we travel around the world building bunkers. Now, this particular bunker I wanted to show you is one that it's under construction at the moment in central Congo. It's a small one. It's a bunker that's about 24 metres wide and about 200 metres long, centre fill, so the oil will be filling down the centre. Now, what I wanted to show you is a lot of people ask about how we keep bunkers dry. Very, very important that we don't allow the moisture or any rainfall to run into the bunker. And if you look at this particular bunker is designed with earth walls for the first year, and you can see, looking at it, you can see the earth walls. Now, the top section comes to about the centre of this earth wall, goes to the other side, so we'll have a 26-degree angle of repose in the grain. When it rains, the water will run this way into this ditch and run left to right with a fall of about 1 in 1,000. And you can see how it's shaped on either side so the water doesn't penetrate or come near this wall. Now, eventually we will dig this wall out and we'll put a steel or a concrete wall in place, and that wall will go in about the centre of this berm area here. Now, we can use berms, earth walls, to start out with, and that gives us a pretty good little bunker to start with, but you can see that the compaction is very important, and I'm going to try and show you my boot here as I dig. You can see how hard that is. So we've used rhyolite in this case, and of course any compactable material, we check it to see how well it compacts, and of course it has to be extremely hard for heavy trucks to be running on them. You can see this is about the centre of the bunker. Now, this fall is falling from the centre. You can think a roadway, 1 in 4,000 to the wall, either side. Extremely hard. Now, as I said, we'll be filling this from the centre. We can also fill bunkers from the side, which allows us to put loading equipment on the sides of the bunker. But you can see with this, we are still doing earthworks here. So this is the first bunker here to go in, and walking up onto this wall, you'll see the second wall. So there's 24 metres from this wall to that wall, with the placement of the auger in the centre. But what I wanted to show you was the cross section. That's really what I'm interested in talking about in this video, and how we get rid of water. So you can see here what we have is that we have a ditch. On the outside of the wall we have an earthen wall. Now, that could either be steel or concrete, but we'd still recommend that you'd have a rise to the wall, so that when the rain comes off, it runs into this ditch and runs away. And you can see this next rise here. We're starting to rise now into the second bunker. So this is the beginning. You can see we've dug it out at this stage. We will backfill in here, bring more rhyolite in and compact it. And if you have a look on the other side there, you will see piles of rhyolite ready to come in. This bunker is ready to start using. Now, all we have to do, you can see over here, if you have a look, go walk through the ditch, you can see the water. Now, this is quite high. We're looking at, from the top of this wall, we're looking at 650 mil, 700 millimetres from where I'm standing now to the base of the drain. Now, we're very, very sure in this case that no water will run back in. And if we dig this out, and when we dig this out rather, to put a concrete wall in, we'll dig about the centre. We'll put a concrete wall into the centre, but we will leave this rise on the other side of the wall to get rid of the water. Now, what I'll do here is we'll take a little walk down here and have a look. I just want you to see the cross section of how this bunker is built from the other side. This is one of the reasons why I'm showing you this particular bunker, because it is not, this one is finished, but the ones next door aren't. But you can see the cross section in this really easily. Okay, so you can see the cross section in the wall, and if you walk along, you can see the drain. Now, this drain falls either way, left or right. depending on how it comes off the tarp. And it's designed never to flood. Right, and they are quite substantial falls. And looking at the cross section from this side, you will see the fall in the bunker. You see it's quite low there, rising up to the centre where it peaks, to the centre, and you're looking at a tarp that's ready to go down for the ground tarp. Centre of the bunker. The fall from the centre to the outside wall is 1 in 4,000. And again, we'll come across this side and have a look. Now, compaction rate on this is as hard as we can possibly get it. When we compact with rhyolite, we use moisture, water in the rhyolite to actually compact it. We roll it, compact it, and it's usable. So you can see here from the other side also, you can see your drain again on the other side, and rising into the next pad. There'll be 4 pads here altogether. Okay, and that's really what I wanted to show you. So, this bunker, like many others, we can go as wide as we like with bunkers, depending on the inloading equipment. Bunkers we make in Australia with outloading or inloading equipment, rather, side loaders, we're going 36, 38, 39 metres wide at the toe, and the toe, in case you're wondering, is this point here. So you can see the wall is leaning back, the camber, and the inside of that is the toe. And the grain will fill from the top of that wall all the way over to the other wall. And we will have equipment running, whilst we're filling it and emptying it, running all over this pad in all conditions, and this pad will not bog. Right, so just a look around so you can get a bit of an idea of what I'm talking about. And you see a wall from one side, looking back at the car, generator set, one of the ground tarps ready to go down. Okay, this is how we construct bunkers. This is how we construct the earthworks, so moisture doesn't get in. Very important. Without the right construction in the beginning, then you run the risk of moisture penetrating the bunker, the grain mass, and rotting the grain from the inside. This type of construction doesn't do that. This is how you construct it. Okay.